Hi again, Zola. Here is our Unit 3 test. I'm going to leave the the Unit 5 and 6 stuff on the vectors. I'm not going to mark that and give you feedback until after you've written the midterm on the calculus section, just so we don't confuse you and you're not thinking about two different topics as you're going into that exam. So let's have a look quickly at your Unit 3 test, and I'll probably end up making you 3 videos, one for each page again. You're calculating your intercepts correctly. The only thing that I would like for you to do differently is write your intercepts as ordered pairs. So at the end, when you've found them, I would like to see you write something like this. And then for your y-intercept, this is the short form we use, yi and xi. I would like for you to write as an ordered pair. Also, it's not wrong what you've got, it's just better form, and that's what you're going to be expected to do at university. So when we get down to B, again, you've calculated your intercepts correctly, and I would just like to see you write them as ordered pairs as opposed to just a value. Usually when we see x equals -3 or y equals 3, we're not looking at it as a point, we're looking at it as the equation of a line, and that's much different than the intercept. So when we get to question 2, with question 2, what you're being asked to do is a little bit different than what you've done here. We're not finding the intercepts. What you're being asked to do here is to find the vertical asymptote. The vertical asymptote on a graph is a vertical line where the graph doesn't cross. So it might come like that, and then afterwards maybe it might do that, but it's never going to cross this dotted line. The way that we find that is we try to make the denominator equal to 0. So in this case, we would factor x squared minus 4 as x minus 2 and x plus 2. And we can see that x values of 2 and minus 2 are going to give us a 0 in the denominator. So now we found the value of our asymptotes. So if we go back over to our graph, let me get rid of this one so we don't confuse things. At positive 2 and minus 2 on the x-axis, we know that we have those dotted lines. What we need to determine is if those lines are going up towards infinity like that, or if they're going down towards negative infinity as they approach the line. The way that we find that out is we do the little test that was referred to in the test question. In number 2, it says to test to see how the curve is behaving near the asymptote. So testing means that we're going to approach, we're looking here just at the asymptote x equals 2, and you would do the same thing to x equals minus 2. We're going to approach from the right, so we're going to sub in a number just a little bit bigger than 2 and see if we get a positive or a negative answer. In this case, we get a positive answer, and that tells us that the function is going up towards positive infinity when it approaches that line from the right. If we put a value slightly less than 2, so that we're approaching 2 from the left of the graph, then we get a negative value, and that tells us that our graph is approaching negative infinity as it gets closer and closer to the line. So that helps us to get an idea of the shape of this graph and what it's going to look like. We're going to also test x equals minus 2 the same way, and I won't do it here, but I imagine what you're going to find is that the graph looks like this, okay? And so I think we're going to end up with an upside down parabola here, and that these parts will look like a hyperbola. You need to do all of the tests in order to fill in all of the blanks and get a full picture of the graph.